All right, let's do a mathematical problem where we have to consider Newton's third and second law. So here we have our rocket is traveling vertically upwards and accelerates by the expulsion of hot gases. What is the net force at which the gases are expelled by the rocket? Okay, so we see here we need to make the assumption that the force of the rocket being propelled upwards is the same as the negative force of the gases propelling downwards. So the gases are pushing down from the rocket and therefore it's pushing the rocket up. So we need to make this assumption using, this is Newton's third law. And then we also need to use the formula F is equal to m times a. This is Newton's second law. Alright, so I'm going to write out everything I know and kind of get stuff organized. So all my information about my rocket, what do I know about my rocket? Well, the mass of my rocket is 9.8 times 10 to the 3 kilograms. My initial velocity of my rocket is 11 meters per second, and my final velocity of my rocket is 22 meters per second. The time it takes for the rocket to go to this final velocity is 0.75 seconds. Now you may wonder, okay, and I use my acceleration due to gravity. No. We only use acceleration due to gravity when something is falling, okay? This rocket is not falling, it is being propelled upwards. So we need to find acceleration. We've been given initial m final velocity, the time it takes. This is all information that can lead us to finding the acceleration of the rocket. So the formula that we can use for acceleration is A is equal to Vf minus Vi over t. If we plug that all in, A is equal to 22 meters per second minus 11 meters per second divided by 0.75 seconds. Put that into your calculator and it's equal to 14.6 repeating meters per second squared. So this is all information that I found out about my rocket. So now I can take my mass of my rocket and my acceleration of my rocket, mass and acceleration, to find my F net of my rocket. So now F net is equal to m times by a. We put that in, so my mass is 9.8 times 10 to the 2 kilograms multiplied by 14.6 repeating meters per second squared. So my F net then of the rocket is 143,733 newtons. Okay, again, this is of my rocket. Now, I made the assumption that the force of my rocket is equal to the negative force of my gas. It's for every action, there is an equal and opposite reaction. So then I can say my F net of my gases, I'm just going to put gases there just to remind myself that this is of my gases, is negative 143,733 newtons. Okay, well now I'm going to put this into sig digs. And instead of using a negative, I can quantify that as being down. So transferring our negative value into an actual direction. So my final answer, this is to 2 sig digs, so we'll need to go into scientific notation. So my F net of my gases is equal to negative 1.4 times 10 to the 5 newtons, comma, down. And And that's how we apply both Newton's third and second law to a mathematical problem.